Hey everyone, welcome back. Ready to dive into something pretty amazing.
Absolutely.
Today we're going to tackle Kafka.
Sounds good.
You know, you might not realize it, but Kafka is kind of quietly powering so many of the things, the features that we use every day online.
It really is.
But before we get into all that, I want to try and paint a picture here. Like, imagine, um, if you will, the internet's data, all of it, as an actual flood.
Okay, I can see that.
We're talking trillions of clicks, searches, likes, every little thing that you do online. It's creating this massive torrent of information.
Yeah, that's a pretty good analogy.
Yeah, I think so. And that's exactly where Kafka comes in. It's built not just to handle this massive amount of data, but to actually make sense of it.
Yeah, it's pretty incredible how it does that.
So I want to bring in our expert here. Maybe you can give us a little bit of a better understanding of just how crucial this log data really is.
Sure. What's really interesting is that it's not just about tracking website visits anymore. This log data, as it's called, it's become like the lifeblood of these modern internet companies.
Oh, interesting.
Yeah, like think about like how search algorithms are getting smarter over time,
Right.
or how the recommendations that you get are more personalized, or even how security features are evolving to keep us safe online.
Uh-huh.
It's all fueled by this constant, massive stream of information.
So, I mean, we've established that there is just this insane amount of data flowing around at all times.
Yeah.
So how does Kafka actually, I don't know, like wrangle it all? I
Yeah.
mean, we already have things like email, cloud storage, what makes Kafka so special for this?
Yeah, you're right. There are tons of ways to move data around, but Kafka is really purpose-built for this specific challenge.
Okay.
So it's what's known as a distributed messaging system,
Okay.
and it's designed to be incredibly efficient at collecting and delivering these huge volumes of log data. So imagine it like a network of pipelines, all perfectly optimized to transport this data from its source to wherever it needs to go.
Okay, starting to get the picture here.
Right.
So what makes these Kafka pipelines better than anything else?
Well, I think one of the biggest things is its storage strategy.
Okay.
Kafka takes a very minimalist approach to storing data.
Okay.
It uses a very simple log-like structure, and this allows it to really cleverly leverage your operating system's built-in page cache, which is way more efficient for log data than constantly loading everything into memory like some other systems do.
So it's kind of playing it smart, using what's already there and available instead of trying to reinvent the wheel.
Exactly,
Yeah.
exactly. And it goes even deeper than that, actually.
Mhm.
Kafka optimizes like every step of that data transfer process.
Okay.
So it batches messages together for efficient delivery, and it uses something called the send file API.
Okay.
Now, this is getting a bit technical, but basically what this does is it lets Kafka hand off the data directly from the operating system to the network, and that minimizes the need to copy data back and forth, which is a really big deal when you're dealing with, these insane amounts of data.
Yeah, absolutely.
Yeah.
So we can see that speed and efficiency are like really baked into Kafka's DNA here.
For sure.
But how does it actually handle the scale that we're talking about?
Yes.
Spreading all of this data across multiple computers.
Right. Well, that's where Kafka's distributed nature really comes into play.
Okay.
So it's designed to run on these clusters of multiple machines, each handling kind of a piece of the data puzzle. Think of it like a really well-coordinated team.
Uh-huh.
Each member has their own specialized task.
Mm.
So the data is organized into what are called topics, and then further divided into these things called partitions.
Okay.
And those partitions are distributed across the entire cluster.
Gotcha.
And that allows the system to scale horizontally by just adding more machines as that data volume grows.
Okay, so we've got this team of machines. They're all working together. But who's like the manager? Who's making sure everyone is doing their job properly?
So this is where Kafka gets really interesting. It doesn't actually have a central boss, or what we call a master node.
Interesting.
Instead, it uses a system called Zookeeper to handle the coordination.
Okay.
So Zookeeper acts like a shared bulletin board, allowing all the brokers to communicate with each other and the consumers to know where to find the data they need.
Okay.
It's a really, really decentralized approach,
Gotcha.
and it makes Kafka incredibly resilient.
Okay.
And it also avoids any single points of failure, which is really important.
So no one is really calling the shots, but everyone is still on the same page. That's pretty efficient.
Right.
But what does this mean for, the machines themselves, the brokers, as we call them?
Yeah.
What's their role in all of this?
So this is another really key design choice in Kafka.
Okay.
And it's that the brokers are what we call stateless. Now, that might sound a bit abstract, but it essentially means they don't have to keep track of which consumers have read which messages.
Interesting.
That responsibility is actually shifted to the consumers themselves.
Hold on. So the brokers are just kind of holding the data,
Yeah,
and then it's up to the consumers to figure out what they've already seen and what they haven't.
exactly.
That's a pretty different approach.
You're right. It is a different approach. And it might sound a little counterintuitive, but it actually has huge advantages.
Okay.
Because by keeping those brokers stateless, Kafka avoids a ton of overhead and complexity.
Mm.
And it makes the system incredibly scalable.
Okay.
Because adding new brokers doesn't require complex synchronization or shuffling data around.
Okay, so we're starting to see how Kafka's design really makes it perfect for this flood of data, right?
Right.
But how does it actually stack up against, like, the competition?
Right.
You mentioned these traditional messaging systems before. Are we talking about just a slight edge, or is Kafka, like, in a whole other league here?
So let's just say it's not even close.
Wow, okay.
The research paper that we're using for this deep dive actually includes these head-to-head performance tests.
Okay.
And the results are really pretty staggering.
Okay.
We kind of Kafka handling like orders of magnitude more data per second than these traditional systems, like ActiveMQ or RabbitMQ.
Orders of magnitude. Wow. Okay, so not just a faster horse. It's like a completely different mode of transportation.
Exactly.
Wow.
But it is important to remember that it's not really about one system being inherently better. It's all about choosing the right tool for the job.
Right.
Traditional messaging systems still definitely have their place. But when it comes to the sheer volume and the speed of this log data, Kafka is in a league of its own.
Okay, so Kafka dominates the performance side of things. But let's get practical here.
Sure.
How are companies actually putting this powerhouse to work in the real world?
Yeah, that's a great question. So I think one of the best known examples is LinkedIn.
Yeah, you mentioned that before.
They were really early adopters of Kafka.
Hmm.
And their use case is a great example of how this system can just simplify even the most complex data pipelines.
Okay.
We'll dive into this a bit more in the next part, but to give you a taste, they were processing like billions of messages per day using Kafka.
Billions. Okay, so this isn't just some theoretical concept here. This is a system that has been, like, battle tested at a massive scale.
Absolutely.
Okay, can't wait to hear more about that.
Yeah. But before we get there, let's touch on one more really crucial aspect of any data system, and that is reliability.
Right, because what good is all this speed and efficiency if the data doesn't actually get where it needs to go, right?
You're absolutely right. And this is where the idea of delivery guarantees comes into play.
Okay.
Kafka, it generally provides what we call at least once delivery,
Okay.
meaning that each message is guaranteed to be delivered at least once to each consumer group.
So, like, no lost mail in Kafka's world.
Well, it's a little more nuanced than that. We'll get into the details in the next part.
Yep.
It involves understanding the trade-offs between durability and throughput
Okay.
and the possibility of duplicate messages.
Gotcha.
But the main takeaway is that Kafka provides a really solid foundation for that reliable data delivery
Okay.
with options to fine-tune it based on, what a specific application needs.
Okay, so there's more to unpack there. But I think we've laid some pretty good groundwork here. We've seen how Kafka is designed to handle this internet data flood, from that clever storage strategy to its unique distributed architecture, its emphasis on efficiency.
Exactly. And we've really only just scratched the surface.
Well, you've certainly piqued my interest. I can't wait to dig deeper into that LinkedIn story and really explore those delivery guarantees in the next part.
Looking forward to it.
Me too. All right, welcome back. So last time we kind of laid the foundation of Kafka, how it handles those massive data streams, its unique design choices, and how it really just outperforms those traditional systems. But I'm ready for some real-world action here.
Okay.
You mentioned LinkedIn before, so let's dive into, like, how they actually put Kafka to work.
Yeah, LinkedIn is it's a fantastic case study.
Mm-hmm.
They were dealing with a data challenge that I think will probably sound pretty familiar to anyone who's working with, large-scale systems.
Yeah.
It's just this ever-growing flood of information, user activity, system metrics, like
Right.
everything you can imagine.
Right.
It was all piling up.
Yeah.
And they needed a better way to manage all of it.
So what was their solution? Did they just, like, throw more servers at the problem?
Well, that's rarely the most elegant solution.
Right.
Instead, they really saw the potential of Kafka, and they saw it early on.
Okay.
Remember how we talked about Kafka's distributed architecture?
Oh.
Well, LinkedIn took full advantage of that.
Yeah.
They actually set up multiple Kafka clusters, each dedicated to a specific purpose. So they had one cluster dedicated to real-time data processing, and then another one for handling offline analysis.
Okay, so they divided and conquered, but what kinds of tasks were those clusters actually like doing?
So the real-time cluster, that was really the heart of their user-facing operation. So think, tracking user activity, feeding data into recommendation algorithms, even powering security features to combat, like spam and abuse.
Hmm.
All that was happening in real time, thanks to Kafka.
So all those features that we just kind of take for granted, they're working seamlessly in the background. They were relying on Kafka to make that happen.
Exactly, yeah.
That's really impressive. But what about that offline cluster? What was its role?
So the offline cluster, that was all about extracting deeper insights from this fire hose of data.
Okay.
So think, feeding information into their data warehouses,
Hmm.
Hadoop systems for like more in-depth analysis and reporting.
Hmm.
And then they could use that data for things like understanding user trends, optimizing website performance, even guiding business decisions.
So it's like they had these different lanes for their data, each one kind of optimized for a specific, speed and purpose.
Exactly. And the sheer volume of data that they were processing it was mind-boggling. Billions of messages flowing through these Kafka pipelines every single day.
Yeah.
It's a real testament to, how Kafka can handle even the most demanding workloads.
Billions? Okay, billions with a B. That's serious data. But with so much information flying around, like how did they make sure nothing slipped through the cracks?
Right.
Data integrity must have been like a huge concern.
Absolutely. You can have the fastest data pipeline in the world, but if it's not reliable, then it's ultimately useless. And LinkedIn was very aware of this. So they actually implemented a really clever auditing system using Kafka itself.
Okay, now you've got me intrigued.
Yeah.
How did they pull that off?
Well, so remember how each message in Kafka carries a timestamp and the server name where it originated.
Right, like a digital fingerprint almost.
Exactly. So LinkedIn leveraged that information to create a dedicated topic in Kafka, specifically for monitoring events.
Okay.
So producers, those are the systems that are feeding data into Kafka, they would periodically send messages to this monitoring topic,
Okay.
reporting how many messages they had published within like a specific time frame.
So it's like each producer is keeping tabs on its own output and reporting back to a central log.
Exactly. On the consumer side, so those systems receiving data from Kafka,
Uh-huh.
they would do the same thing. They would track how many messages they had received,
Mm-hmm.
and then they would compare their count against those monitoring events from the producers.
So if the numbers matched up, then they knew everything was flowing smoothly.
Yeah.
And if there was a discrepancy, then they had an indication that something was amiss.
Exactly. So it was a brilliantly simple way to maintain that really high level of confidence in their data pipeline. It allowed them to catch like potential data loss really early on and pinpoint the source of the issue.
That's really impressive. It really highlights how Kafka can be used for more than just moving data around, right?
Yeah.
Like they actually built this whole auditing system on top of it.
Right.
But I'm also curious about how they integrated Kafka with their other systems, especially their Hadoop clusters for that offline analysis.
Yeah, so that's another area where their implementation really shines. So they created this specialized input format that allowed their MapReduce jobs, which is a core part of Hadoop, to read data directly from Kafka.
Okay, so no need to like copy massive amounts of data around. That sounds way more efficient.
Yeah, it was a game changer for them. It
Yes.
streamlined their data processing pipeline. It eliminated the need for all those intermediate storage steps.
Mhm.
And plus, remember how Kafka's brokers are stateless?
Yeah.
That meant those MapReduce jobs could easily handle restarts and failures
Mhm.
without having to worry about like duplicating or losing data.
Right, because it's the consumer, not the broker, that's keeping track of their progress. It's like it's all coming together now.
Exactly. But there's one more piece of the puzzle I want to highlight here, and that's their use of Avro for data serialization.
Okay, now we're getting into like the nitty-gritty, the technical nitty-gritty here.
Yeah.
I know Avro is a data serialization format, but what makes it so special in this context?
So Avro is known for its efficiency and its ability to handle schema evolution.
Okay.
So think of it as like a blueprint for your data.
Okay.
It allows you to define the structure of your data in a really clear way.
Right.
And crucially, make changes to that structure over time without breaking compatibility with like older data.
So as their data needs evolve, they didn't have to like rebuild their entire system from scratch.
Exactly, yeah. And to make sure that everyone was on the same page, they used Avro to enforce a contract, essentially, between data producers and consumers. So it was like a shared language,
Okay.
ensuring that all the systems could understand and interpret the data correctly.
Smart move. With so many different systems interacting, it's easy for things to, like, get out of sync.
Right.
But that, like, well-defined schema, it keeps everything running smoothly.
Right. And they even set up a schema registry service. It acted like this central library where consumers could easily find the correct schema for each message they received.
Hmm.
And this guaranteed that, like, data could be decoded correctly, even as the structure of the data changed over time.
Wow, that's a lot of foresight. It sounds like LinkedIn really thought through, like, every detail here.
They did, and it paid off. Their implementation of Kafka wasn't just about moving data quickly. It was about moving it reliably, efficiently, and with like a level of sophistication that was really impressive.
It's a fantastic example of how a really well-designed data architecture can just be, like, a game changer for a company. But I can't help but wonder, with all this talk about data integrity, what happens if a broker fails? Does the entire system just, like, grind to a halt?
That's a great question, and it brings us to one of the limitations of Kafka as it existed, back then.
Okay.
If a broker went down, any data stored on it that hadn't been fully consumed, that would become unavailable.
Uh-oh. That sounds like a potential single point of failure.
It was. But it's important to understand this in the context of like Kafka's evolution, right?
Okay.
Back then, the focus was on achieving that unprecedented throughput and scalability,
Uh-huh.
but the need for, greater fault tolerance and durability, that was becoming clear.
So how did Kafka address that challenge?
That's exactly what we're going to explore in the final part of our deep dive. We'll delve into this world of delivery guarantees. We'll unpack those nuances of data durability, and we'll look at how Kafka has evolved to really meet the demands of even the most mission-critical applications.
Sounds like we're about to get into some seriously deep technical waters here.
We are, but I think you'll find it fascinating. We'll uncover the mechanisms Kafka uses to guarantee that reliable data delivery.
Okay.
We'll explore the trade-offs involved, and we'll even peek into the future of this remarkable system.
Can't wait. Join us for that final part of our deep dive into Kafka, where we'll wrap up this exploration and leave you with some thought-provoking questions about the future of data. Welcome back to the final part of our Kafka deep dive. So we spent the last two parts exploring the ins and outs of the system, its unique design, how it can handle those insane amounts of data, and we even got a glimpse into the real world with LinkedIn's story.
Yeah, it's pretty impressive stuff.
It is. But now it's time to tackle that one crucial piece of the puzzle that we haven't fully explored yet. How does Kafka guarantee that your data is going to actually get where it needs to go?
That's a great point. I mean, in the world of data, reliability is everything. You can imagine crucial information just vanishing into thin air. It's a recipe for disaster.
Exactly.
So let's unpack how Kafka makes sure your data actually reaches its destination safely, and we'll explore those delivery guarantees that we've touched on before.
Okay, so, if we think back to the last part, we were talking about the possibility of data loss if a broker fails.
Right.
So how has Kafka evolved to address that vulnerability?
Well, you've hit on a really key evolution in Kafka's journey, and it all comes down to one word: replication.
Okay.
Think of it like having backup copies of your data spread across multiple brokers. So if one broker goes down, the system can seamlessly just switch over to another copy, and that makes sure no data is lost.
So it's like having a safety net for your data. Right?
Exactly. Replication just adds this whole other layer of resilience to Kafka.
Okay.
And it's not just about, simple backups. There are actually different approaches to replication, each with their own kind of trade-offs.
Mm-hmm.
So, for example, you have asynchronous replication, which really prioritizes speed. And then you have synchronous replication, which emphasizes consistency.
Okay, so you can choose the level of redundancy that you need based on how critical the data actually is.
Exactly.
But okay, so let's get back to those delivery guarantees.
Okay.
How does replication actually impact whether a message is going to be delivered once, twice, or even, more times?
That's a great question. So, generally, Kafka provides what we call at least once delivery.
Okay.
And this means that it guarantees each message will be delivered to the consumer at least once. This is usually good enough for a lot of applications, especially when you're dealing with things like log data, where a duplicate message here and there isn't really a big deal.
Right, but I think you mentioned before that there are certain situations, like financial transactions, for example, where those duplicates could cause some serious problems.
Oh,
So
absolutely.
how do you handle those cases?
Right.
So in those scenarios where duplicates could really mess things up, applications need to actually implement what's called deduplication logic.
Right.
Kafka doesn't have like built-in exactly once delivery. However, it does give applications the tools that they need to deal with those duplicates effectively.
Okay, so it's kind of a shared responsibility then.
Yeah,
Kafka provides the foundation, the solid base for reliable delivery, and then the application developer needs to add that extra layer of protection if they need it.
exactly. And it's an important concept to understand about Kafka. It's incredibly flexible and adaptable. You can really use it for a huge range of use cases. But let's zoom out for a second and look at the bigger picture here.
Okay.
When we talk about these delivery guarantees, we also need to remember the trade-off between durability and throughput.
Right, because we can't just focus on reliability. We need to make sure it's fast as well.
Absolutely, yeah. For some applications, raw speed is king.
Even if that means, taking on a bit of a higher risk of maybe losing some data.
Right.
Others might say, no, absolute data integrity is what matters most, even if that means sacrificing some performance.
Right.
And the beauty of Kafka is that it actually gives you the ability to fine-tune this balance based on what you need.
It's really fascinating to see how Kafka kind of walks this tightrope between reliability and performance. But I have to admit, learning all this, it's hard not to get excited about the future of this technology. Like, what's on the horizon? What's coming next for Kafka?
Well, one of the most exciting developments is this emergence of stream processing capabilities
Mhm.
directly within Kafka.
Oh, wow. Okay.
So imagine being able to actually analyze data in real time as it's flowing through the system
Wow.
without having to move it to like a separate processing engine.
That sounds incredibly powerful. I mean, what kind of possibilities does that open up?
Oh, there's so many. Think like real-time fraud detection or personalized recommendations that adapt instantly to what a user's doing. Or even things like dynamic pricing models that can actually respond to the market in real time.
Wow.
It's really about making data actionable. It's about taking those insights and turning them into instant responses.
It's like having a brain built into the data pipeline itself.
Yeah,
No more delays, no more batch processing, just instant insights driving immediate actions.
exactly.
It feels like we're entering a whole new era of data-driven decision-making.
We are. And Kafka is at the forefront of this whole revolution. It's not just about moving data anymore. It's about understanding it, processing it, acting on it all in real time.
It's been an incredible journey exploring the world of Kafka with you. We've uncovered its really ingenious design. We've seen how it can handle data at a scale that's almost impossible to even imagine. And we've explored the mechanisms that it uses to make sure that your data is safe and it's going to get to where it needs to go.
Yeah, absolutely.
But I think what I find most exciting is just the sheer potential that it unlocks for the future.
Oh, I agree. Kafka has already changed the way we handle data, and it doesn't look like it's slowing down anytime soon.
So, to our listeners out there, we encourage you. Dive deeper, explore further, discover what you can build with this incredible tool. Who knows? Maybe you'll be the one pioneering that next big breakthrough in the world of data. Until next time, keep exploring.